Today we're going to be going over Unit 10, Section 4, which talks about tessellations. What are they? Well, we've got uniform, not uniform, regular, and semi-regular. A tessellation is shapes that make up a two-dimensional plane with no gaps, and these are not random shapes, but it's a pattern. See, both of these are patterns. There's no gaps, and if you kept going, it would fill up a whole two-dimensional plane. The sum of the measures of the angles like so, surrounding a vertex, which is a single point, is 360. A regular tessellation uses only one type of polygon, and it's a regular polygon. Regular means all sides are congruent, all angles are congruent. The regular polygon also has, to make a tessellation, an interior angle that has a factor of 360. If that is the case, it will tessellate. Now, let's refresh our memory what I mean by interior angle. Last unit section, we learned about this process. Well, if I take a pentagon, it has 5 sides. So here, 360, divide by 5, 72. These add up to 180. So 180 minus 72, we get 108. A pentagon will not tessellate because the angles are not a factor of 360. 360 divided by 108 turns out to 3 point something. It's not a whole number. You have to have a whole pentagon. So back here, I can take squares and I can make a tessellation. I could also take hexagons and make a tessellation. You actually see a hexagon tessellation in nature, a honeycomb. Only 3 regular polygons tessellate by themselves. A regular triangle, a regular quadrilateral, and a regular hexagon. No other polygon that is regular tessellates by itself. Uniform tessellations is the idea that the arrangement of shapes is such that the vertex always has the same number of angles. So here, right here, we've got 2 octagons and 1 square. No matter where you go, it's always the same. 2 octagons and a square. Now over here, you see the same idea. Every vertex has the same set of angles. That makes it a uniform tessellation. Now this is an example of something that's not uniform. Look at the angles. Here, this vertex, 1, 2, 3, 4, 5, 6 angles, but this vertex, 3 angles. That's not the same. It's not that they have a different number of angles, the fact that they are different angles. 120, 120, 120, 60, 60, 60, 60, 60. A semi-regular tessellation is a uniform tessellation that contains 2 or more regular polygons. So here, I have octagons and quadrilaterals. Again, it's uniform because look at the angles. It's always the same at each vertex. So let's review. Regular. One shape only, and that one shape is a regular polygon, which is only triangles, squares, hexagons. Semiregular, two or more shapes, and those shapes are regular polygons. And in the semiregular, it could be any polygon. It could be an octagon, it could be a pentagon. You could do it with all sorts of semi-regular polygons. Uniform. Every vertex is the same. Has the same number of angles, and all those angles have the same degrees. So let's look at some examples. Can I make a semi-regular tessellation from each of these sets? Now these are all regular. These are all regular polygons. Now, the way to determine if I can do this is not by trying to, actually arrange it and be like, oh, does this fit here? Does that fit there? No, it's actually look at the interior angles. So just like I did back here, I'm looking at the interior angles. Because each vertex on a tessellation, on a semi-regular tessellation, has to add up to 360. So on a pentagon, its interior angle is 108. On a triangle, each interior angle is 60. Is it possible to take some combination of this and get to 360? It's not. It's not possible. And I could try 108 plus 108 plus 108. Well, that's 324. Can I add 60? No, that's over 360. It's not possible. I can try every combination I want, and I will not get it to work. Next one. A regular dodecagon. Now remember, a dodecagon has how many sides? 1, 2, 3, 4. We can keep counting. 12 sides. This has 3 sides. So let's do the math. What's the interior angle of a dodecagon? Let's see. The number of sides is 12, so 360 divided by 12, 30. 180 minus 30 is 150. Okay, so I got 150. We know the interior angle of a triangle is 60. Let's see, 150 plus 150 plus 60. That's 360. I can make a tessellation using these shapes. Regular octagon. Regular octagon, we know the angles add up to triangle. Let's see if we can find a combination. Let's see, 135 plus 135, that's 270. Let's see, I add 60. No, that didn't work. Alright, let's look at the next set. Determine whether each polygon tessellates the plane. If so, we're going to describe, is it uniform, is it regular, not uniform, semi-regular? Well, here we've got a rhombus. So since it's a rhombus, I know it's not regular because rhombuses are not regular quadrilaterals. Now a rhombus, if I think about this, I know this angle and this angle are congruent. I know this angle and this angle are congruent. And I know all of them add up to 360. I know a rhombus will tessellate. Any quadrilateral tessellates. And I can show it by actually doing it. Look at that. I can make a shape. I can make a tessellate. Isosceles, trapezoid, and square. I can make this tessellate as well. Now, I'm sorry, I didn't describe this. This is uniform, and that's it. It's not regular. It's not semi-regular, because semi-regular requires 2 or more regular polygons. Isosceles, trapezoid, and square. I know it's not regular, because, well, trapezoid's not regular. I know it's not semi-regular, because semi-regular requires 2 or more regular polygons. So it's either uniform or it's not uniform, or it doesn't tessellate. Let's find out. I'm going to clone this. No, he doesn't fit there, does he? But wait. He fit there. I'm going to clone the square. Now I'm treating this as one whole shape unto itself. Looks legit so far. Can I put him there? Oh, no, that's going to have an empty gap. I could put him here, but I have nothing here. This shape as a whole cannot tessellate. Now, I could make this tessellate if I didn't make that one whole shape. In other words, if this was not a whole unit by itself, I could do it. In other words, just one square and one trapezoid. I could make it work. But as one whole unit, I can't make it work. This will not tessellate. Alright, we're going to look at these. Do they tessellate? Both of them tessellate. We're going to describe it. Each vertex is the same. We have a square and octagon. This is semi-regular. And it's uniform. That is a parallelogram, therefore it's not regular, but it is uniform. We'll be doing some more examples in class. See you next class.